Okay, everybody. So here we read, the ordered pairs in the table represent the possible images of the point x comma y, p x comma y, on the graph of the function y equals f of x. Okay, and so you can see the points listed off there. The question says, if f of x undergoes the following single transformations, then the coordinates of the corresponding points on the function, okay, blah, 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 and we're looking for point number. Now, I probably shouldn't say single transformations. It looks like there's more than one transformation going on there, so it's probably not the best idea to say that. But here we go. So take a look at the first one. So what we're going to notice is, first of all, there's a vertical reflection. Okay, that's making the y coordinate negative. And then everything else that's happening in there is going to be horizontal. So what I'm looking for here, first of all, points where the y coordinate is negative. And I can see points 1, 3, and 7 very specifically have just the y coordinate becoming negative. Then inside here we see that if we factor out the 2 to separate the translation and the stretch, that there's a horizontal stretch by a factor of 1/2, and it's been moved 2 units to the right. So I'm looking for a multiple of 1/2, adding 2, and then the y coordinate is negative, and that's 0.3. In the next one, most of the work that's being done here is actually occurring on this thing vertically. There's 2 out front, so there's a stretch by a factor of 2, and then at the end we're subtracting 4. So I'm looking for 2 times y minus 4, and actually it turns out the only point that does that is 0.4. I don't even really have to look at the x coordinate to know that that's got to be 0.4. However, I will notice that it's just a horizontal reflection, which means that the x coordinate is becoming negative, and in 0.4, that's exactly what's going on. For question, I guess it would be the third question here. Y equals -2 f of negative x plus 4. So there's a -2 out front. That has already been moved away from the y coordinate, so I know that what I'm seeing is the actual transformation that it's trying to communicate here. I would be multiplying the y coordinate by -2. There's going to be a vertical reflection and a vertical stretch by a factor of 2. So now I'm looking up and down my points. Where do I multiply the y coordinate by -2? And the answer is it's either 0.5 or 0.6. Now inside the function, I have to factor away the negative, and so I can see that there's going to be a horizontal reflection, and then I'm going to move the point or the graph here 4 to the right. I'm going to add 4, so it's going to change the sign on the x to a negative and then add 4. And then I already knew that it was either 0.5 or 6, and 6 is where I'm adding that 4. So it becomes negative, and then I add 4. For this last one here, I've got f of -2x plus 4. The only part that's affecting the vertical or the y coordinate there is going to be that plus 4. So I'm looking for points that are adding 4 to the y, and that's either going to be 0.2 or 0.8. And then inside here, I'm looking at a horizontal reflection, so a negative sign, and then a stretch by a factor, a horizontal stretch by a factor of 1/2. Remember, to get the x by itself, I'd have to divide out by that 2, so it's going to give me that 1/2 there. And I knew it was either 0.2 or 0.8. In this case, it would have to be 0.2.